Period, frequency, and rotational velocity. The time it takes for an object to complete one trip around a circular path is called its period. The symbol for period is capital T. Periods are measured in units of time. We will usually use seconds. Often we are given the time it takes for an object to make a number of trips around a circular path. In that case, the period is equal to the time it takes for the object to make the number of trips divided by the number of trips. The number of revolutions that an object completes in a given amount of time is called the frequency of its motion. The symbol for frequency is lowercase f. Frequencies are measured in units of revolutions per unit time. We will usually use 1 over seconds, or seconds to the negative 1 power. Another name for this is hertz. Frequency can also be measured in revolutions per minute or second, etc. Often we are given the time it takes for an object to make a number of revolutions. In that case, the frequency is the number of revolutions divided by the time it takes. Since period is t over n and frequency is n over t, these two quantities are inverses of each other. So we can also say that the period is 1 over the frequency and the frequency is 1 over the period. Remember from kinematics, we define the speed of an object as speed is equal to distance over time. For an object moving in a circle, instead of using any old time, we're going to use the period, the time it takes to travel around the circle once. To find the speed, we then also need to know the distance around a circle, and another name for that is called circumference. The circumference of a circle is given by 2 pi r, and the time it takes to go around once is the period t. And the object's speed is speed equals distance over time. So the distance becomes 2 pi r, and the time is capital T. So velocity is equal to 2 pi r over the period. Velocity must always have a magnitude and a direction. So the magnitude is v equals 2 pi r over t. If an object is in uniform circular motion, the direction of its velocity is always changing. And we say that the velocity is tangent to the circular motion. Now since f is equal to 1 over t, we can replace t in the denominator with f. So another equation for velocity is v equals 2 pi rf. And of course the direction of the velocity is still tangent to its circular motion.